Let's take a look at this function. We're going to find the areas of increase and decrease by finding the derivative, of course. So f prime of x is 3x squared minus 6x minus 9. And actually, it's much easier if we just find out where this is 0, and then we'll fill in the blanks. So we're actually finding the critical numbers. And then so this is going to be 3 times x squared minus 2x minus 3. So x minus 3 and x plus 1. So x equals 3 and x equals -1 are critical numbers. So now I will make a little sign chart, and then I will summarize. So remember, the sign chart is not the answer. It's just a tool that we're going to use. X equals 3. And I'm going to find test points in between here. And so let's see, put that there. And so let's just try, let's see, maybe I'll just, put that over there, just for clarity. Okay, so f prime of, say, negative, let's pick a nice small, well, -2. Is equal to, I can plug this into this function up here. And let's see, 3 times, excuse me, -5, -1. It looks like that's going to be 15. So that's positive. F prime of 0. Always use 0 if you can, because that makes things easy. So that's a negative slope. And then f prime of, how about 10? Just to make things, let's go with 4. I got scared of the 10. Anyway, so 4, I've got 1, 5, 15. So that's positive. So let's see, we have increasing. You can either write this like this, negative infinity to -1, and probably this is the easiest way to write it. And then decreasing is going to be in the middle there. Local maximum and minimum values, those are the actual values. So f of -1, this is going to be a maximum, a local maximum, because you're increasing then decreasing there. So f of -1, I go back to the original function and plug -1 into that, and I get -4, +5, so +32 is a local max. And then f of 3, so let's see, can I plug 3 into this? I'll actually write it out because I'm scared of getting this one wrong. It'll be 27 minus 27 minus 27 plus 27. Oh, interesting, is 0 is a local min. Intervals of concavity, to do this, I'm going to need to know the second derivative. So we have the first derivative up here. So that's going to equal 6x minus 6. Set this equal to 0. Oh, I guess that both here and above, I should be concerned with places that this is undefined. However, this is a polynomial, so it's not undefined anywhere. It's a nice function. Okay, so set this equal to 0. I get x equals 1. We're going to do the same thing. So x equals 1. And I'm going to do the second derivative now. So let's do the second derivative for a number less than 1. So that's going to be negative, meaning concave down. And then f double prime of something bigger than 1, say 2. is equal to positive 6, so that's going to be concave up. So concave down will be from negative infinity to 1, everything less than 1. Concave up will be from 1 to infinity. Okay, sketch the graph of the, wait, where did my D go? Oh, there it is. Find points of inflection. So 1 is a point of, x equals 1 is the x value for a point of inflection because that's where concavity changes from positive to negative, or rather negative to positive. I just need to know the function value at that point. So let's see, I'm going to just plug this in. Hopefully I'll get this right. Here, I'll do it. F of 1. And so that's 27 minus 9 is negative, is 18, 15, 16. So this is a point of inflection. Now let's try to sketch a graph. Just do the best you can with this. So I've got my axes. That's pretty good. On those axes, I will put the important points. It looks like x equals -1, x equals 3, and x equals 1. So let's see, -1, 1, and 3. Doing the best I can there. And then I will actually plot those points. 1, it looks like 16. I'll do that. 16 and 32. Okay. 116 is the point of inflection. -1 and it's 32, is that right? Yes. That is going to be my maximum. 3 and -1 will be my minimum. Or sorry, 3 and 0. Wasn't that right? Yeah, 3 and 0. Let's see, I'm just gonna slide this over a bit. Now let's do the best we can to connect these dots in some sort of a way that makes sense. So concave down from less than 1. So I'm going to go concave down, like that, and then concave up. Try to hit that minimum as best I can, something like this. If you graph this on a computer or calculator, it will look a little bit better than mine, but this is a general idea of what this graph looks like. Well, let's do the same thing with this problem. This one's going to be a little bit more complicated because of those fractional exponents, but let's not let that deter us. So f prime is going to be 5/3 times 1/5 times x minus 4 using the chain rule. Okay, plus 2/3 times 2 times x minus 4 to the -1/3. So right off the bat, I see that there's going to be an issue here with that negative exponent. I'm going to clean this up a bit. And I get 1/3 x minus 4 to the 2/3 plus 4/3 x minus 4 to the -1/3. Okay, so that negative exponent there means that this will be undefined when x equals 4. So that's the first thing to note. The second thing is we want to know where this is equal to 0. And so let's set this equal to 0. 1/3 x minus 4 to the 2/3 plus 4/3 x minus 4 to the -1/3 is equal to 0. So I'm going to multiply everything. No. I'm going to just move one of the fractions over to the left. So we have x minus 4 to the 2/3 over 3. is equal to negative 4 over 3 x minus 4 to the 1/3. And I need to make more room. Okay, so at this point, we can you can think of this in a bunch of different ways, but multiply both sides by x minus 4 to the 1/3, or 3 times x minus 4 to the 1/3 power. We can do that because we've already accounted for when x equals 4. So as long as x doesn't equal 4, we're going to proceed this way. So that will give me x minus 4 is equal to negative 4. So that means x equals 0. Okay, so we have the critical numbers. So this is equal to 0. Yeah, it just looks fishy to me, but I'm going to go with it. Yeah, I'm confident of my algebra, and so this is f prime of x equals 0 when x equals 0. Okay, so those are the two critical numbers, and so we're just going to be concerned with what's happening in between them. So let's draw our little number line. Here's x equals 0. Here's x equals 4. Oh, and on either side of them. So we're going to compute f prime right here. So f prime of, let's pick a number like negative 1. That'll do it, I think. Yeah, this one's harder than I thought. You know what? I need to rearrange my function. Hold on a sec. To make it a little bit easier. So here's what I'm going to do is I'm just going to rearrange this a bit and write it like this. X minus 4 plus 4 over 3 x minus 4 to the 1/3. And that's equal to x over 3 x minus 4 to the 1/3. Okay, so that's going to be a lot easier to parse when we deal with this stuff. So let's just move this down a bit. Okay. So we'll pick something like f prime of negative 3. I don't know. You can pick any negative number you'd like, and that is going to be less than 0. Greater than 0. Yeah, it really doesn't matter what the value is, but if you do this, you can do this in your head. I'll talk you through it. Negative 3 on top of this fraction, 3 times the cube root of negative 7 on the bottom of the fraction, and that is going to be a negative number over a negative number, which is going to be positive. So then we can do f prime of 3 now. Here we'll have a positive number over a negative number, which is going to be less than 0. And then f prime of, pick a number bigger than 4, like 10. That'll be positive over positive, which is greater than 0. So this will be increasing when from negative infinity to 0 and from 4 to infinity, and decreasing from 0 to 4. Okay, minimum and maximum values. You can see that we're going to increase then decrease between at x equals 4, and so x equals 0. So x equals 0 must be a local max. F of 0. Going up to the original function, it looks like the original function I get negative 4 to the 5/3 over 5 plus 2 times negative 4 to the 2/3. That's not very nice. Okay, I'm going to do my best to work this one out for you. So this will be negative 4 times negative 4 to the 2/3 over 5 plus 2 times negative 4 to the 2/3. Okay, when you add these together, I guess that's going to be 6/5 times negative 4 to the 2/3, which is the same as 6 times the cube root of 16 over 5. That might look a little more pleasing. Okay, so that's my local maximum. Local minimum is much easier. That's at x equals 4. Let me just slide this over to make some room. So x equals 4 is a local minimum, and f of 4 is 0. That one's easy. You can hopefully do it in your head. Concavity, we need to know the second derivative. So where am I with my first derivative? I don't know which one is going to be worse. Maybe I'll take this one, pull this one down, just to remind me where I am. I'm not thrilled with this, but I'm going to do it. So f prime of x is that. And so the second derivative using the quotient rule, it's going to be 3 times the cube root of x minus 4 times 1 minus 2/3. So that's going to be 2x minus 4 to the negative 2/3. Yeah, that's not going to be nice. Okay, well, probably would have been easier to start with this other one. Well, I'm where I am, so let's go ahead and do it. I'm going to just rewrite this like this. 3x minus 4 to the 1/3, 2x times x minus 4 to the negative 2/3 times, let's just do this, 1/9. So the 9 gets taken care of. Negative 2/3. There. Now I'll just distribute this across. Hey. Okay, so we have to do two things to this. We have to find out where does this equal 0 and where is this undefined. So it's pretty obvious that x equals 4 is going to be a problem. So x equals 4 will be an undefined point, but let's actually work out what this is. Let's see, I'm going to turn this into a single fraction again. Yeah, I probably could have done this much easier another way. Okay, so this is going to be, how about this? 3 times x minus 4 over 9 times x minus 4 to the 4/3 is 2x. Yeah, the algebra is going to be a problem. Okay, I know I'm combining these as a single fraction, so let's see, 3x minus 12 minus 2x all over 9 times x minus 4 to the 4/3. So that's the second derivative. So we have f double prime of x is undefined at x equals 4, and f double prime of x equals 0 at x equals 12. I guess I kind of, here, I'll just do this. So all that's left is to figure out, whoops, that's not a 4. What's happening to the second derivative on each of these intervals. And so if you'll forgive me for just doing it, the second derivative of, let's do 0, because that's a nice easy number to work with, is going to be less than 0. So they'll be concave down. F double prime of, say, 10 is also less than 0. So that's also concave down. And then f double prime of, say, 20 is greater than 0. You could do this on a calculator, but it's really not too bad to just, all I care about is whether this is positive or negative. And so there's the situation there. So maybe I should summarize. Concave down is going to be, I guess it's everything less than 12. So x is less than 12. So I could write this as negative infinity to 12. And then concave up will be from 12 to infinity, everything bigger than 12. So you have this weird point, but let's not worry about that. We'll get to that in a minute. We have a point of inflection at x equals 12. So 12, I need to know f of 12. So that's going to be 1/5 times 8 to the 5/3 plus 2 times 8 to the 2/3, whatever that is. So you know what I'm going to do is I'm going to pause this and compute all of these things on my calculator and get back to you. I'll just get my decimals. So I had to pause the video because I was having a problem, and I found my problem. So you might have seen it, and there's my problem. So let's get rid of that problem. Whoops, it keeps coming back. Hold on a sec. Let's do this. Come on. There it is. Okay, so with that 2 gone, let's see if I can track it all the way through without having to do too much extra work. This is gone. This becomes a 1 here. Here we go. This is a 1. That's this right here. Then up here, this becomes a 1. I think that's the main issue. And then this is a 2. There. So that changes this. That was my big issue. Now let's fix the rest of this mess. So let's see, this doesn't make any sense anymore. So we will use 6. So we have 4 and 6. And pick a number between there. We're going to use 5, and that is still true. And then this is all true. So that's where we are with this. Sorry about that. And then, so yeah, I was having trouble with all of this mess. So let's go back and let's deal with the points of inflection. Let's see if I can do this. So at x equals 12, we've already dealt with x equals 4, have we not? Yes, we have. There it is. There's x equals 4. So x equals 12. Or not x equals 12, x equals 6. F of 6. Let's see if I can work this one out. Here's the function itself. I'm going to stick that over here. So let's see, it's going to be 1/5 times 2 to the 5/3 plus 2 times 2 to the 2/3. Okay, that feels better to me. Just it wasn't working out. So this will be 1/5. Let's see, 5/3. That's 2 to the 2/3 times 2 to the 3/3. 2 to the 3/3 is 2. Okay, so let's see. This is going to be 2, that's going to be 6 to 12 times 2 to the, let's just go with the cube root of 4 all over 5. How's that? So there's that's going to be the y value. Now sketching the graph, that's going to be fun because I ostensibly was pausing in order to compute the values as decimals, and then I got distracted because I was wrong and I needed to fix my mistake. So I guess I'll pause again. All right, so I have no idea if what my decimal is the same as this, but this I got by actually plugging in 6 into the original function, and so we're just going to go with it. So we have 0 and 3. And same with this, 3.02 here. So let's just put 3 somewhere. I need 4, I need 6. How's this? You know what, this is terrible. Let's start fresh. 4, 6. Okay, so I know that point is correct. That's the easy one. We're going to put this right about here, which is around 3. And then this point right here. Okay, so let's deal with what's going on. We're concave down. Still have that 12 lurking. Concave down between, let's see, from negative infinity to 6. How in the world could that be? Oh, I see how it could be. We're going to go concave down. So going along here, I can go like this. This is not going to be very convincing. I'm going to move this dot up a bit so that it's more obvious how this is looking. So we're going to be going down, 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 down. Then we have a corner, and it goes up. And then it starts right there. It'll start doing this sort of a deal. So concave down, concave up. And that's the best I can do. Just a sec. I'm actually gonna, I've got the graph. I'm looking at it. So that is gonna have to be the best that we do. You know what, this thing, actually, now that I'm looking at the graph, this thing actually keeps going down like that. I don't know what that point is back there, but this is the important stuff. I guess we have, sorry, yeah, I just realized I have to have a maximum because we're going to be concave down. There we go. That's much better. I completely neglected to think in terms of this slope being 0. Okay, now we're all set. Hopefully this is it, and I'm all done.